Okay, so today we're going to focus on area of rectangles, squares, and triangles. We're going to revisit some special right triangles first, just to make sure that we recall our 45, 45, 90 and our 30, 60, 90 right triangles. So kind of taking it back to earlier in the semester, for our 30, 60, 90 triangle, recall that we always labeled our triangle. So this is my hypotenuse. Across from my 60-degree angle, this is my long leg, or LL. Across my 30-degree angle, we have our short leg. And then we have that right angle here, okay? And if my short leg was 1, then I would have to double that to get my hypotenuse, and then multiply 1 by √3 to then get my long leg. So thinking about our shortcuts, we would do our short leg times 2 to give us our hypotenuse. We would do our short leg times √3 to get our long leg. We would do our hypotenuse divided by 2 to get our short leg, and then our long leg divided by √3 to then get our short leg. So we had 1, 2, 3, 4 formulas for this one problem, for this one type of triangle. So make sure you go back and review that. This will come up within this unit. You will not get a cheat sheet like we had in the past units, so make sure that you know these properties. And then for a 45, 45, 90 triangle, if you recall, if this length was 1 and this length was 1, we multiplied the length of the side by the square root of 2 to then get the hypotenuse. So it was the leg times √2 to get us our hypotenuse, or the hypotenuse divided by √2 to get a leg, okay, in a 45, 45, 90. And a 45, 45, 90 is also called an isosceles right triangle, okay? So just kind of reminding us of these triangles and the formulas. We're going to be using them quite a bit throughout this unit. Okay, so a reminder from yesterday, the area of a square is side squared. And then if we're trying to find the area of this square, notice how we are given a 45-degree angle and we're given 5. 5 is this diagonal. So you could go back to the previous slide. If we're given the diagonal, that's equivalent to our hypotenuse. And to find the length of a leg, we have to do the hypotenuse divided by √2 to give us our leg. So 5 divided by √2 should give me a leg. So in order to find out the length of that leg, we multiply by √2 over √2 and rationalize. So 5 √2 over 2 is a leg. But now it's asking to find the area. Find the area. And now the area is side squared. So the side we know is 5 √2 over 2, but we're squaring it. So what this is essentially saying is take 5 √2 over 2 and multiply it by 5 √2 over 2. So let's go through this together. 5 times 5, that gets us 25. And then √2 times √2 gives us 2. And then 2 times 2 gives us 4. So when we reduce, we end up with 25 over 2. That is the area, 25 over 2 units squared. You could leave it as a improper fraction, or we can use a mixed number if you prefer. But make sure to include your units. So this one's a little bit tougher because it's involving the special right triangles, and we have to remind ourselves how to find the sides of a triangle given the hypotenuse, and kind of bringing all these, the quadrilateral unit and the special right triangle unit together. Okay, so a reminder, we have the area of a rectangle, we have base times height, And here we have right angles, and I have this side as a 6, okay? It's a 6. And we know that this angle is 60, so the angle next to it has to be 30. And so this angle down here has to be 30 as well, and then 60. So because a rectangle is a parallelogram, we know that the opposite angles have to be congruent, and we know all the angles have to be 90. So we're only given a base. We're not given the height, okay? So in order to find the height, we need to use this triangle that we have. So if I redraw this, we have a 60-degree angle and a 30-degree angle. Across from the 60, that's my long leg. So that length is 6. And then across from the 30 is my short leg. And so in order to get from your long leg to your short leg, we have to divide this long leg by √3 and then rationalize. So we have 6 √3 over 3, which gives us 2 √3 is the length of the height, or is the height. So now if we're looking in the formula, area is base times height, we know that the base is 6 and the height is 2 √3. And now we have to multiply. So 6 times 2 √3 gives us 12 √3. It's a 3, not a 5. Units squared. So again, this may look like a simple problem because you're like, fine, the area of a rectangle is base times height, but we have to remember, we have to be able to find the base and the height if we are given 30, 60, 90, or 45, 45, 90 right triangles. Okay, so now we have the area of a triangle. And you may remember this from a prior class. This all should be information we brought into this class with us, but there are two ways we could see the area of a triangle. 1/2 base times height, or base times height over 2. Either one will work for me, but your base and height, when you're plugging it in, must always be perpendicular. So if I have this problem here, my height may be outside of this triangle. This could be my height, and then this length could be my base. And then also here, if I have an isosceles or equilateral triangle, our height may have to be dropped down, and that can be our height, and then our base is this side. So we're going to be working with a bunch of different triangles, but we always need to make sure that the base and height are perpendicular. That is the key point here. So let's practice with the area of a triangle. Okay, we want to find the area of an isosceles triangle with sides 10, 10, and 16. So let's draw an isosceles triangle. Both sides are congruent, and the side lengths are 10, 10, and then this is 16. So if we're looking at this, we don't have a base or a height yet, but we have special properties of isosceles triangles that we could use. What if we drop this altitude down this way? That is considered our height. And so if we knew what this height was, then we could do our base times our height gives us the, divided by 2, gives us the area of this whole triangle. So when we drop this altitude down, it also creates 2 congruent pieces. So each of these are 8 and 8. And now if we're thinking about this triangle, we have our height, 8 and 10. So if we think back to Pythagorean theorem and Pythagorean triples, this is a 6, 8, 10 right triangle. So our height ends up being 6. Again, we can always use our Pythagorean theorem and say h squared plus 8 squared equals 10 squared, and then solve for h. But then you know you'll always get 6 because of this Pythagorean triple. So if that's the way you want to find it, that's okay. But make note that we have Pythagorean triples that will come up in this unit as well. So now we have our height is 6, and our base, the whole base, is 16. So we have 6 times 16 over 2 is our area. So from here, we don't have to multiply the 6 times the 16, but what I can do, I can reduce. So I can say 2 goes into 16 8 times, and then I can do 6 times 8. That gives me 48 square units. So there's going to be things that we're going to have to do to these triangles in order to find the base and the height. And the base and the height are going to always be perpendicular. Let's look at this problem. We want to find the area of an equilateral triangle. So if it's equilateral, we know it's equally angular. And if it's equally angular, we know all of the angles are 60 degrees. And if all of the side lengths are 10. So for this problem too, if we drop an altitude down, we know that our whole base is 10. But if we know that this is isosceles and equilateral, 10 split up, we have 5. So we have a 5 here and a 10 here, but this angle is 60, which makes the angle across from it 30. So we have a 30, 60, 90 right triangle. So if this is across from the 30, this is my short leg. So to get my long leg, which is my height, I got to multiply 5 by root 3. So we got 5 root 3 here. So the area of a triangle is base times height over 2. So our whole base is 10, and the height we found was 5 root 3, and we're dividing that by 2. So again, we can reduce before we multiply, and say if 2 goes into 10 5 times, and do 25 root 3 square units is the area of this triangle. And the last question that we're going to look at is we want to find the area of an isosceles right triangle. So let me draw a right triangle. And now if I want to make it isosceles, we know that the angles are 45 and 45. So if the hypotenuse is 20, how do I find the length of a side, the length of a leg? I need to divide 20 by the square root of 2. And then rationalize. So we have 10 root 2 are the length of the legs. So remember we said that the base and the height must always be perpendicular. So we are choosing this leg and this leg to be our base and our height because they are perpendicular. So 10 root 2 times 10 root 2 divided by 2. So that gives us 100 times 2 over 2. And those reduce, so we get 100 square units.